In this video, we are going to learn about arithmetic sequences. The first type of formula that we're going to learn for arithmetic sequences is called the recursive formula. Before we get into that, let's figure out what an arithmetic sequence is. So, a sequence is an ordered list of numbers that often form a pattern. Each number in the list is called a term of the sequence. When you can identify a pattern in a sequence, you can extend the sequence. Need help identifying the pattern? Try taking the second term minus the first term, and then the third term minus the second term, and so on. If the pattern is the same every time, if you're always adding the same number or subtracting the same number, then that is an arithmetic sequence. So in an arithmetic sequence, the difference between consecutive terms is the same. So again, you are either adding the same number every time or subtracting the same number every time. The difference is called the common difference. The common difference is also the same thing as the rate of change or slope of a function. We use the variable d to represent the common difference. In these first examples, it says state if the sequence is arithmetic. If it is, what is the common difference? So let's look at example 1. How do I go from 3 to 8? Well, we add 5. How do I go from 8 to 13? Add 5. How do I go from 13 to 18? Add 5. Were we adding the same number every time? Yes, so this is arithmetic. The common difference d is 5. Now, if you're like, okay, I'm not really sure how you knew the pattern so easily. If you're getting stuck, do the second term minus the first term. So my second term is 8 minus the first term is 3. 8 minus 3 is 5. Let's try that again by doing the third term minus the second term. The third term is 13 minus the second term is 8. 13 minus 8 is 5. Let's try that again with the next one. Let's do the fourth term minus the third term. The fourth term, right, because 1, 2, 3, 4. The fourth term is 18 minus the third term is 13. 18 minus 13 is 5. Because we got 5 every time, it is arithmetic, and then the common difference is 5. So if you're ever having a hard time identifying the pattern, try doing this over here. Let's look at example 2. To go from 6 to 9, I add 3. To go from 9 to 13, I add 4. And to go from 13 to 18, I add 5. Did we add the same number every time? No. This is definitely a pattern. It's just not an arithmetic pattern. You always need to add or subtract the same number every time. So this is not arithmetic. If it's not arithmetic, then it doesn't have a common difference. Let's look at example 3. On example 3, how do I go from 10 to 4? Well, I subtract 6. How do I go from 4 to negative 2? Subtract 6. How do I go from negative 2 to negative 8? Subtract 6. So is this one arithmetic? Yes. What did we add or subtract every time? Negative 6. So because we were subtracting 6 every time, that made this arithmetic, and then our common difference d is negative 6. For example 4, to go from 2 to negative 2, I subtract 4. To go from negative 2 to positive 2, I add 4. To go from 2 to negative 2, I subtract 4. Here I definitely have a pattern, but I'm not adding or subtracting the same number every time. It either needs to be all adding or all subtracting. Because I'm alternate, subtract, add, subtract, it's not the same. So this one is not arithmetic. If you're like Miss Benson, I notice another pattern here. The other pattern is multiplying by -1. Yes, that is another type of pattern that you could have, but because you're multiplying, it is still not arithmetic. So again, an arithmetic sequence is when you add or subtract the same number every time. These two are definitely patterns, they're just not arithmetic sequences. So let's look at the next page. It says writing a recursive formula. A sequence is a function whose domain is a set of natural numbers. So numbers 1, 2, 3, 4, and so on, the numbers that you count with, and whose range are the terms of the sequence. You can write a sequence using a recursive formula. A recursive formula is a function rule that relates each term of a sequence after the first term to the ones before it. The recursive formula is a sub m equals a sub n minus 1 plus d, where the first term, a sub 1, is given. So here is that formula again. A sub n is the value of the nth term. So whatever term you're trying to find, that's the term value. So if I'm trying to find the 10th term, that value would be here. If I was trying to find the 12th term, then that value would be here. A sub n minus 1 is the value of the term before the nth term. So if this was the 10th term, then this would be the 9th term. And if this was the 12th term, then this would be the 11th term. D is your common difference. And then whenever you're doing a recursive formula, they have to give you the first term. So a sub 1 is saying, hey, the first term equals, and then they tell you whatever the first term is. So let's look at that on examples 5 and 6. It says write a recursive formula for the arithmetic sequence, then find the 5th and 6th terms. So if you look, this is the first term, the second term, the third term, the fourth term, and so on. So let's look for the pattern here. How do I go from 7 to 11? I add 4. How do I go to 11 to 15? Add 4. How do I go from 15 to 19? I add 4. So this is arithmetic, and my common difference D is 4. When you write your formula, again, your formula is this up here. All you are doing is replacing the common difference D with whatever that value is, and then you're stating what the first term is. Those are the only two things that are changing. Everything else in the formula will stay the same. Notice how these n's are written down low. So like your A, your equal sign, your A, your plus sign, all of that's written at the same level, but this n is written down low, and this n minus 1 is written down low. So here my formula will be a sub n equals a sub n minus 1 plus d. What was our common difference? Our common difference D was 4. And then we want to state what the first term is. My first term was 7. This is your formula. A sub m equals a sub n plus minus 1 plus 4, where a sub 1 is 7. A sub 5 is telling you to find the 5th term. So what term would come next? Well, if I add 4, what's 19 plus 4? 23. A sub 6 is telling us to find the 6th term. Well, what's 23 plus 4? 27. Let's look at example 6. Here we want to do the same thing. So the first thing that we're going to do is we are going to identify the pattern. How do I go from 91 to 84? Subtract 7. How do I go from 84 to 77? Subtract 7. How do I go from 77 to 70? Subtract 7. So my common difference D is -7. in my formula, all you replace is your common difference d with your pattern, and a sub 1, you state the first term. So here my formula is going to be a sub m equals a sub n minus 1. And when you're doing this, make sure your n and your n minus 1 is written smaller and down low. And then plus d. So here that's going to be plus -7, or you could just write -7. And then we want to state what our first term is. My first term was 91. For a sub 5, they want to know, hey, what's the fifth term? Well, I would need to subtract 7 again. 70 minus 7 is 63. For a sub 6, we want to find the sixth term. So I would need to subtract 7 again. 63 minus 7 is 56.